Welcome to my channel. Today we are going to solve problem number 110 on Leetcode to check whether the given binary tree is balanced binary tree or not. Using this problem we can able to complete two things on tree. First thing is height, how to calculate the height of the tree, and then what is balanced binary tree. So here uh, the definition of balanced binary tree is given, like if a tree in which left and right subtree of every node differs in height by no more than 1. So let's take an example of this tree. So if we have tree like this, 3 3 9 20 57. So 3 9 20, then 15 and 7, 15 and 7. So what our function should return? It is balanced binary tree, that is true. So why? Because the for any node, the left subtree height and right subtree height should have difference not more than 1. That means maximum possible difference is 1. So here let's try to calculate for this node. So for this node, left subtree height is 1, right subtree height is uh, 1 and 2. So 2. Difference between them is 1. 2 minus 1 is 1. Okay, here no left node, no right node. So left subtree and right subtree height is 0. Here for this node, left height is 1, right subtree height is 1. 1 minus 1 equal to 0. So here height is 0, here here difference is 0. So in this way, for all the nodes we are having answer is either 1 or less than 1. Okay, so that's why this function should return for this tree true, because this is balanced binary tree. But suppose if we have one more node here, let's say 21. So in this case, uh, the left subtree height will remain same 1, but right subtree height will be 3. Okay, so this will become 3. So 1 minus 3 will be 2. Okay, minus 2, but in terms of height it is 2. So this is not a balanced binary tree. Why? Because the difference between left subtree and right subtree height is greater than 1. So I hope you understood this concept. So now let's try to solve this problem on Leetcode. So what we need to do, we need to first calculate, we need to modify one function which is generally used for calculating the height of binary tree. So how we calculate the height of binary tree? A height, since then that function will return true. Okay, and let's say height of bt. Okay, and what it will accept? It will accept tree node as a parameter. And what it will return? It will return the height of the binary tree. So it will return the height. Okay, so if the root is null, that means if root is not there, a root is null, then we are going to return 0. There is no node. Okay, then what we have to do? We have to calculate it for left subtree and right subtree. So root arrow left, and then similar thing we have to do for root arrow right. This is standard procedure we will follow for calculating the height of binary tree. Then we will modify this function to solve to check whether the tree is balanced binary tree or not. So int I left height, okay, and int I right height, okay, left height and right height. And then how we are going to return the height? Height will be maximum of left height or right height plus 1, plus 1 for root node, 1 for root node. Okay, So this will be the height for any given node. Okay, so left subtree height and right subtree height. So based on whether left height or right height, whichever is greater, plus 1 for considering current node. So in this way we are going to return the height of a tree. So now we are going to call this function using, and if it returns -1, that means error, then we are going to return false. If it returns true, then we are going to return true. Okay, so if it is -1, that means we have found any such subtree where the difference is not matching the given criteria for height of left subtree and right subtree. Difference is greater than 1. So how to modify this height function? So here, if -1 is equal to left height, then we are returning -1, return -1. Again same thing, if right height is -1, then what we are going to return? -1. Now one more possible condition is returning false is if absolute difference between left height and right height, absolute difference between left height and height is greater than 1, then also we are going to return false. That means return -1, which will return internally false. Okay, using this function. So this is the just simple modification in the height of binary tree to check whether the tree is balanced binary tree or not. So let's try to run it for sample test case. Okay, here no matching call for absolute. Okay, absolute difference between I right is there, I left is there, and absolute should present actually in std. Oh, sorry, I miss. Hopefully this will work. No, again there is one more problem at line number 39. What exactly it is? Okay, here we have missed the semicolon. Height of binary tree. Of here we have to pass only the parameter height of bt. Oh no, again semicolon missed. Yeah, so our sample test case got accepted. Now let's try to run it for all the test cases by submitting this. Yeah, correct. So our solution got accepted and all the test cases were passed. So I will put the link of this source code from my GitHub repo to the description box. So please do check it out. If you found this video useful, then please like the video, share it with your friends, subscribe to my channel and press bell icon for future updates. Happy coding. Thank you.